So we're going to move on to section 5, which is measuring and constructing angles. Pretty much we're going to do this stuff in class, but what I want to give you guys today is basically some definitions, so I'll have you write these definitions down, and hopefully I can get it to you pretty quickly. So here we're going to talk about naming angles, basically what an angle is. So what you need to know, if I can pull up my little arrow here, an angle is a set of points consisting of two different rays. So if you think of that, we have a ray that's right here that goes out this way, and then we have a ray that goes this way. So when you put those together, they share the same endpoint. That's called the vertex. Okay, and then the rays are the sides of the, so these are the sides. So this is side 1, or whatever you want to call it. This is side AC or side AB. Those are the rays. Now, you can name this, many different ways you can name this angle. You can either call it angle A, or you could call it angle CAB, or angle BAC. So that's right here, written out for you. That's the way you want to write it. And if you notice, the vertex is always in the middle. It has to be in the middle, okay? See that the A is the vertex, it's always in the middle. Or if they have a 1 here, or a 2, or 3, or a 5, or a 6, you can name it that way. So use the number, such as angle 1. The next thing that we need to talk about is the region that contains all points between the sides of the angles is the interior. So all the points that are inside here is the interior of the angle. So think of inside. If you have your interior walls, you are inside. Or if you are outside, those are your exterior. This would be the exterior of the angle. So exterior is outside, interior is inside. So let's look at this crude drawing of an angle that I just drew. It's tough to draw with the stylus, as you guys know. So we have J, M, K, K, M, L. Now if I asked you to go ahead and name 2 angles or 3 angles, so go ahead and name 3 angles that are, push pause, name 3 angles that are in this particular diagram. So if you said angle JMK, angle KML, and angle JML, you are correct. So if you notice, what do you notice about what's in the middle? What do we call that? You got it, vertex. So the next thing you need to know is the different types of angles. And you might have talked about this in middle school, where this is the first one right here, which is an acute angle. This is measures greater than 0 in less than 90 degrees. So if you can think of, I think of it as something that's small. Acute puppy small, so it's acute. It's smaller than 90 degrees. It's less than 90 degrees. You have a right angle, which we all know that. We've been talking about that, is a 90-degree angle. Now obtuse, this measures greater than 90 degrees and less than 180. So if you think of obtuse, that means big, that means larger, so that means it's going to be greater than 90. And then you have a straight line. And some people might say, well, that's a straight line. Well, in reality, it's an angle. Okay, it measures 180. It is an angle. So if you, these are the 4 different things right here. You need to know those, so put those into your notes. The next thing I want to talk about is congruent angles. What congruent angles are is when you have 2 angles that have the same measure. So I'm going to try to freehand this. So let's say if I have this angle right here, let's call it angle A, B, C, and let's say I have this other angle, then I'm going to try to draw the same, and if I measured it, we'll pretend like it would be the same, and we'll just call it D, E, F. So the way that you show that these are congruent is you draw in these congruent marks. This right here would be a congruent mark, so that tells the reader that they're both the same. So if you see those right there and right there, if you see that, you know automatically that those 2 angles are the same. So angle ABC is congruent to angle DEF. The way we'd write that is angle ABC is congruent to angle DEF. So here we'll take a look at bisecting angles. Before we talked about segment bisectors, well, if you can think a segment bisector, well, what does a segment bisector do? It cut a segment in half. Well, the same concept applies here. As an angle bisector is a ray that divides an angle into 2 angles that are congruent. So in this figure, we have ray YW. Basically, that is the angle bisector. And the way you know that is those little congruent marks. So I know that XYW is congruent to angle WYZ. So that's what this is saying right here. We know that they're congruent by those marks. We also know that if they told us that this was the angle bisector. You can use a compass and straight edge to bisect an angle, and that's something that we'll actually do next class. I figured I'll just show you that in class. So that's pretty much the notes for 1.5. So we want to make sure that come up with a question, right? So make sure you come up with a question. It could be any three. Remember, it can be a HOT question, HOT, higher order thinking question. It can be a confusion question, or it could be an example. Or it can be an example. So make sure you do that. Make sure you have that, and I'll see you next class.